We live in a remarkable time in our planet and the solar system's history, a time when one species, Homo sapiens, has become the dominant force of change on Earth and beyond. It is also a time when human activity has left a lasting imprint on the land, the oceans, the atmosphere, and even space. A time that some scientists call the Anthropocene, the age of humans. Humans have been altering the natural environment for thousands of years through practices like hunting, farming, mining, logging, and fishing. But in the last 2 centuries, the pace and scale of human impact have increased exponentially, driven by the population's rapid growth, economy, technology, and consumption. Today, more than 7.8 billion people inhabit the Earth, and more than half live in urban areas. Cities cover only 3% of the land surface, but they consume 75% of the world's resources and produce 80% of the global greenhouse gas emissions. Agriculture occupies 40% of the land and uses 70% of the fresh water. Industry produces goods and services that satisfy human needs and wants, but also generate waste and population that harm the environment and human health. Human activity has also created a global culture transcending geographical and political boundaries. Art, music, literature, religion, science, and philosophy are expressions of human creativity and diversity that enrich our lives and shape our worldviews. Technologies such as the internet, social media, and artificial intelligence enables us to communicate, collaborate, and innovate across distances and disciplines. The Anthropocene is not only a time of unprecedented human influence, but also a time of unprecedented human vulnerability. The same activities that have enabled human progress and prosperity have created a series of interconnected and complex problems that threaten the stability and sustainability of our civilization and the planet. In the face of challenges in the Anthropocene era, humans have showcased remarkable achievements and opportunities through exploration and innovation. Space exploration stands out as a symbol of human curiosity and resilience, with achievements like reaching the moon and exploring other planets. Additionally, advancements in renewable energy, derived from natural sources like the sun and wind, offer a sustainable alternative to fossil fuels, addressing climate change concerns. Further accomplishments include progress in medicine, the invention of the internet, and the development of artificial intelligence, showcasing humanity's ongoing commitment to overcoming obstacles and expanding horizons. Some possible future developments and events that could happen in the Anthropocene are colonizing Mars, terraforming Venus, building space elevators, and encountering alien life either in the solar system or beyond. But the Anthropocene is only a blink of an eye in the cosmic calendar, the scale that measures the universe's history from the Big Bang to the present. The cosmic calendar comprises the 13.8 billion years of the universe into a single year, with each month representing about 1.15 billion years, each day about 38 million years, and each second about 440 years. On this scale, the Anthropocene would last less than a second, and the entire human history would be a fraction of a second. The degenerate era is estimated to begin around 100 trillion years from now and to end around 1 duodecillion years from now. It is the era when most of the stars in the universe will have exhausted their nuclear fuel and become degenerate remnants, such as white dwarfs, neutron stars, or black holes. It is also the era when the galaxies will drift apart, collide, or merge, forming new structures and patterns. It is the era when the universe will expand, cool, and darken, and when the stars and the galaxies will be the major sources of light and energy. In about 1 billion years, the sun will become 10% brighter and hotter, increasing the average temperature on Earth by about 10 degrees. This will cause the oceans to evaporate, the atmosphere to lose water vapor, and the greenhouse gas effect to intensify. The Earth will become a hot and dry planet, unable to support life. In about 5 billion years, the sun will enter the red giant phase, a stage when it will expand and swell, reaching up to 250 times its current size. The sun will engulf the inner planets, including Mercury, Venus, and possibly Earth, destroying them completely. The Sun will also lose mass and gravity, causing the outer planet's orbits to widen and become more eccentric. In about 8 billion years, the Sun will shed its outer layers, forming a planetary nebula, a cloud of gas and dust that surrounds the core. The core will become a white dwarf, a small and dense remnant that will slowly cool and fade over time. The white dwarf will be about the size of the Earth, but with the Sun's mass. It will emit a faint and steady light, but it will not have any nuclear reactions. The Sun is not the only star in the universe. There are about 100 billion stars in our galaxy, the Milky Way, and about 2 trillion galaxies in the observable universe, each containing billions or trillions of stars. The red dwarfs will eventually become white dwarfs, like the Sun, but they will take much longer to do so. The blue giants will also become red giants, but they will have much more violent and spectacular deaths, exploding as supernovae, powerful explosions that can outshine entire galaxies. They will leave behind neutron stars, extremely dense remnants that have the mass of the Sun but the size of a city, or black holes, regions of space where gravity is so strong that nothing, not even light, can escape. The Milky Way and Andromeda are on a collision course because of their mutual attraction. They are expected to collide and merge in about 4 billion years, forming a new and larger elliptical galaxy called Milkomeda or Milkdromeda. The collision and merger will trigger a burst of star formation and evolution as the gas and dust in the galaxies will be compressed and ignited. The collision and merger will also affect the orbits and positions of the stars and the planets, but it is unlikely that they will collide directly due to the vast distances between them. The galaxies are not the only things that are moving and changing in the universe. The universe itself is also evolving and transforming, following the laws of physics and cosmology. The universe started very hot and dense, with a temperature of about 10 raised to the power 32, which is 1 decillion degrees Kelvin. The universe cooled down as it expanded, reaching a temperature of about 2.7 degrees Kelvin today. The universe will continue to cool down as it expands, reaching a temperature of near absolute zero, or 0 degrees Kelvin in the far future. One of the future eras is the black hole era, the extreme future of the universe when only black holes remain. The black hole era is estimated to begin around 10 raised to the 40, 1 duodecillion years from now, and to end around 10 raised to the 100, 1 googol years from now. It is the era when most of the matter and radiation in the universe will have been consumed by black holes, the regions of space where gravity is so strong that nothing, not even light, can escape. The black holes will dominate the universe in the black hole era, as they will be the only objects that can survive the expansion and cooling of the universe. The black holes will consume the remaining matter and radiation in the universe, such as the degenerate remnants of stars, the rogue planets, the interstellar gas and dust, and the cosmic microwave background. The black holes will also interact with each other, forming larger and more massive black holes or emitting gravitational waves that ripple through time and space. It is also the era when the black holes will evaporate and decay, leaving behind only elementary particles and photons. It is the era when the universe will approach a state of maximum entropy and minimum complexity, and when the black holes will be the last bastions of order and information. The black hole era is not only a time of decay and dissolution, but also a time of potential and opportunity. Many possible developments and events could happen in this time scale, ranging from plausible to speculative, from mundane to extraordinary. For example, the formation of new structures and patterns such as the iron stars, hypothetical objects that could form from the fusion of iron nuclei in the cores of white dwarfs, or the black hole atoms, hypothetical objects that could form from the quantum interactions between mini black holes and elementary particles. The emergence of quantum fluctuations such as the quantum foam, the seething and bubbling of space and time at the smallest scales, or the quantum tunneling, the phenomenon that allows particles to pass through barriers that they normally cannot. The existence of exotic phenomena such as the wormholes, the shortcuts or bridges that connect distant points in space and time, or the baby universes, the offshoots or branches that split from the main universe. The black hole era is a time of paradox and contrast, of order and chaos, of simplicity and complexity, of information and entropy. It is a time that challenges our understanding of the universe and ourselves, and that invites us to explore and speculate. Another era is the dark era, the ultimate fate of the universe when nothing remains. The dark era is estimated to begin around 1 Quintillion years from now and to last indefinitely. It is the era when all the matter and radiation in the universe will have been either consumed by black holes, evaporated by Hawking radiation, or diluted by the universe's expansion. It is also the era when all the structure and complexity in the universe will have been either destroyed by entropy, decayed by quantum tunneling, or erased by quantum fluctuations. The dark era will be a time of complete emptiness and silence, with no stars, no galaxies, no planets, no atoms, no molecules, no particles, no photons, no waves, no fields, no forces, no laws, no constants, no information, no computation, no communication, no observation, no interaction, no causation, no correlation, no variation, no change, no event, no history, no future, no life, no intelligence, no consciousness, no awareness, no perception, no sensation, no emotion, no thought, no memory, no imagination, no creativity, no expression, no language, no meaning, no purpose, no value, no beauty, no joy, no hope, no nothing. It is the era when the universe will become a featureless void with no matter, energy, structure, or life. The dark era is not only a time of nothingness, but also a time of zero. Zero is the number that represents the absence or the minimum of a quantity or quality. The dark era will be a time of zero, as the universe will reach the minimum of everything. The universe will reach the minimum of temperature, as it will cool down to absolute zero, or 0 degrees Kelvin, the lowest possible temperature, where all the thermal motion and energy of matter will cease. The universe will reach the minimum of entropy as it approaches the state of maximum disorder and randomness, where all the information and complexity of matter will vanish. The universe will reach the minimum density as it will dilute to the point of vacuum, where all the matter and radiation will be spread out to the point of insignificance. The universe will reach the minimum of time as it will slow down to the point of stasis, where all the changes and events of matter will stop. The dark era will be a time of zero, as the universe will have no meaning or purpose. The universe will have no meaning as it will have no context or reference, no significance or relevance, no function or role, no goal or objective, no intention or direction, no reason or cause, no explanation or justification, no understanding or comprehension, no creation or destruction, no birth or death, no life or non-life, no existence or non-existence, no being or non-being, no nothing or something. The dark era is not only a time of nothingness and zero, but also a time of impossibility. Impossibility is the state or condition of being impossible, of being unable to happen, to exist, or to be done. Impossibility is the opposite of possibility, of being able to happen, to exist, or to be done. Impossibility is also the limit of possibility, being the boundary or the edge of what can happen, what can exist, or what can be done. The dark era will be a time of impossibility, as the universe will have no possibility of anything. And that's it for this video. If you want to see more videos like this, click the cards on your screen.